Okay, so we are going to be doing problems today that use the formulas that I have on this sheet below. I also attached the formula sheet in a link at the top of this unit. And you can go ahead and use that if you'd like. So it's on the formula sheet for aerospace. I'll actually open that so you guys can see the formula sheet that you guys had last year and the year before will also be provided to you again if we end up having to do the end of course assessment. And there's a whole page at the very back for aerospace equations. The ones that we're using today have to do with atmosphere parameters. So those are down here. I have taken a picture of that and inserted it here on the lesson so that way it's a quick reference for you. So I'm going to go ahead and do the very first problem of your practice tonight, which talks about an F-35 that's flying at 1,026 kilometers per hour at 8,350 meters high. And it asks for the air temperature, assuming that the standard surface temperature of 15 degrees Celsius, which is already built into the equation here, 15.04. And we are to show all of our calculations. So if you look at the formula, here, we have an equation for temperature. It asks us specifically for temperature, so we're going to calculate temperature. Temperature is equal to 15.04 minus a coefficient of 0.00649 times the height. H is height. Again, those can all be found down here. A height in this case of 8,350 meters. Okay, so now doing the math on that, we have, grab my calculator here. So I'm gonna first do the 0.00649 times my 8,350 to get 54.1915. I'm gonna take my 15.04 and subtract that answer. Okay, subtract that answer. And we get a temperature of negative 39.15 degrees Celsius. This is in degrees Celsius. Okay, so that is our final answer for this first one. I will warn you that in the problems moving forward, they may ask you for the density. In order to have the density, and maybe they'll give you the temperature. In order to first calculate what the density is, you may need to take that temperature and plug it in here to figure out what the pressure is. And then take that value that you get in order to find the density. So sometimes our density, when we are asked for our density in the problems, which I know you have at least one of those on your problem set, if you are asked for density, a lot of times it's a two-parter where you will first calculate the pressure and then you'll calculate the density. Good luck on your problems, and we will check in again so that way you guys can ask questions on any of the problems that you had.